Okay, we're back again. I apologize for that. The computer froze up on me again. Okay, so we were talking about sum of cubes and difference of cubes. If we look at number 13, I listed off a list of cubes right there. Okay, x cubed is obviously x cubed. 64, now 64 is both a square and a cube, okay? There is no formula for a sum of a cube and a square, okay? So you got both squares are both cubes. So we're going to say this is 64 is 4 cubed. So x cubed and 4 cubed, and we're adding. So my a and my b are x and 4. So we just plug stuff in. A plus b is x plus 4. A squared is x squared minus a times b is x times 4, 4x, plus b squared. B squared is 4 squared, 16. And you're done. That's what's nice. You just multiply it out, or you just put them in the formula and you're done. Now if I multiply this all out, I would get x cubed plus 64. Okay? Let's look at number 15. G3 minus 343. Okay, G is obviously, G cubed is obviously a cube, G cubed, and 343 is 7 cubed. 7 times 7 times 7. This time it's a difference of 2 cubes, okay? So A minus B is G minus 7. Make sure you type in G's, don't type in X's. A squared is G squared, plus A times B is G times 7, 7G, plus B squared is 7 squared. And you're done. So that's what's nice, is you just plug them into the formula. I very likely will give you these formulas on your next test, whenever that is, okay? Let's look at number 17. 17, we have 3h9 minus what? 192h6, 192h6. Okay, so we always try to factor something out first, okay? 3 does go into 192, and I can take an h6 out of each of these. So 3h6 times what is 3h9? h3 minus 3 goes to 192. I think we did this earlier. 3 goes to 192 64 times. And we took h6 out of h6, there's nothing left, okay? This is a difference of 2 cubes. We're going to ignore this. This is part of your answer, but just ignore it right now. This is h cubed, and this is 4 cubed, and it's a difference of 2 cubes. So we're going to have a minus b is h minus 4. A squared is h squared, plus a times b is h times 4, 4h, plus b squared. So plus 4 squared is 16. And don't forget the 3h6 out front. Okay? Okay, the next one, we're skipping 19 and 21. We're on to number 23, question number 23. Okay, so what do we have here? Okay, 23. All right, okay, this looks a little different. I always thought this was kind of a confusing one. The students tend to think this one isn't that bad, okay? These types of problems. We have y3 minus 5y squared. And what? Plus 6y minus 30. Okay, before I actually do this, now first off, what's different about this is we have 4 terms, okay? I don't know if we've ever factored one of 4 terms before, okay? So here's what we're going to do. Before I do this, if I was to ask you something like this, if I give you 3 2x plus 1s plus 5 2x plus 1s. If I was to ask you to simplify that, a lot of students say, well, you distribute and add like terms. You can do that. You definitely can do that. But what I want you to understand is this. We have 3 2x plus 1s plus 5 2x plus 1s. So together we have 8 2x plus 1s. Okay? You can do that because the stuff inside the parentheses is the same. Okay? Now, if it was a 3 2x plus 1s plus 5 4x plus 7s, you can't do that. Okay? You'd have to distribute and combine like terms, stuff like that. But if the stuff inside the parentheses is the same, you can just add what's in front there. Okay, so if I give you 7, 4x minus 9s plus 2, 4x minus 9s, you'd have 9, 4x minus 9s. Okay, if it was minus, you do 7 minus 2, which is 5, 4x minus 9s. Okay, now this is where it gets a little weird. What if I gave you this? 3, 4x plus 1s, plus a 4x plus 1s. Okay, well, we add these together. Be careful. Some students say, well, 3 plus a, that's 3a. No, it's not. 3 plus a is 3 plus a. 3a is 3 times a. We have 3 plus a, 4x plus 1s. We have 3 of them. We have a of them. And what's in the parentheses is the same. We have 3 plus a. What if we had c right here? We have c 4x plus 1s plus a 4x plus 1s. We'd have c plus a 4x plus 1s. Okay? Now, why am I doing that? You'll see here in a second. Okay? Whenever you have 4 terms, you always group them. And you always group, in this class, you always group the first 2 and the last 2. these two, and these two. What can I factor out of each of these? A y squared. Times y is y to the third. Y squared times 5 is 5y squared. What can I factor out of this? Positive 6. Times what is 6y? Ly minus 6 times 5 is 30. Now look what we got here. We got a y minus 5 and we have a y minus 5. What's in the parentheses is the same. How many y minus 5s do we have here? Y squared. How many of them here? 6. So put them together. We put together y squared plus 6, and don't put 6y squared. It's y squared plus 6, y take away 5s. And you're done. Okay? Now, if you didn't catch that, I'd stop it, maybe back up the video and watch it again. But the next one's the same type question, okay? We have 3a3 plus 18a squared plus 8a plus 48. Okay, so is there anything that goes into all of these? You might be thinking 3 goes into them, but 3 doesn't go into 8. Okay, so we just group these. What can I factor out of 3a squared and 18a, or 3a3 and 18a squared? 3a squared times what is 3a3? A. Plus 3a squared times what is 18a squared? 6. And again, we're grouping them because there's 2 and 2. There's 4 altogether. What can I factor out of 8a and 48? 8 times a plus 8 times 6. On these problems, if you do them and the stuff in the parentheses isn't the same, you probably did it wrong, okay? They set them up so you can have the stuff in the parentheses be the same. So we have a plus 6, how many of them? 3a squared, 8 of them here, so we have 3a squared plus 8, a plus 6. Okay, 27, x3 minus 8x squared, is 8x squared minus 4x plus 32. Okay, so what can I factor out of this? X squared times x is x3. Take an x squared out of 8x squared, left with 8. Okay, what can I factor out of these? Well, I can take a 4 out. Now, I will tell you this. If it ever starts off with a negative, whenever you're factoring, if your lead term starts off with a negative, factor the negative out. So don't factor out 4, factor out negative 4. Starting with a negative. Times x is negative 4x. Negative 4 times negative 8 is 32. In the parentheses are the same. We have x squared, take away 4. X minus 8. Be careful, you type that in, the computer's going to say you're wrong. We factored it. Not completely, though. This is a difference of squares. That factors that x plus 2 and x minus 2 times x minus 8. And that definitely doesn't factor any further because everything is first degree. Again, everything doesn't always get to first degree. But if everything does get to first degree, you're done. You're definitely done. If everything is, there's no powers. Okay, 29. 4q3 minus 16q squared. Minus 9q plus 36. Minus 9q. Okay, so what can I factor out of this? A 4q squared times 1. Whoops, not 1, but 1q. Is 4q3 minus, take a 4q squared times 4 is 16q squared. 3 goes into both of these, but actually 9's even bigger, but it starts with a negative, so factor out a negative 9 times q, and negative 9 times negative 4. The stuff in the parentheses is the same, so we have 4q squared minus 9. Q minus 4s. We're not done though, this is also a difference of squares. This is 2q squared and 3 squared. So 2q plus 3, 2q minus 3, q take away 4. Everything's first degree, doesn't factor any further. Okay, 31. 49k4 minus 9. 49k4. Okay, this is a difference. This is kind of weird here, but this is a difference of squares. 9 is a square, it's 3 squared. 49 is 7, and k4 is a square, it's k squared. K squared is k4. I mean, 7k squared is 49k4. So it's going to be 7k squared plus 3 and 7k squared minus 3. So that's a difference of squares. It's just kind of hiding a little bit. Okay? 33. c4 plus 9c squared plus 20. Okay? All right, so we have 3 terms. We draw our 2 sets of parentheses. To make C4, we could have C2, C2, or maybe C1, C3, but there are no C3s or C1s. We do have a C2, so it's probably C2, C2. You look at our last term, it's a positive. It's either plus plus or minus minus. There are no negatives. This is starting off with a 1, so I times to get 20, but add to 9, it's 5 and 4. Now be careful here. Some students might want to factor this further and say, well, those are both squares. It's difference of squares. Difference of squares means subtraction. That's a sum of squares. How do you factor a sum of squares? You can't with real numbers, okay? So that's as far as that one goes. That one doesn't factor any further than that, okay? All right, number 35. Getting closer to being done with this section. This was not an easy section. That's why I think I'm actually giving you an extra day on this one to work on it. This is not an easy section. Okay, 35. 16z4 minus 81. Okay, this is a difference of two squares. This is 4z squared, and 81 is 9 squared. So factors to 4z squared plus 9 and 4z squared minus 9. We're not done though. This is a square, it's 3, and 4 is 2 squared, and z squared is z squared. This is a difference of two squares. This is a sum of squares, which I just told you doesn't factor any further. This one here factors to 2z plus 3, 2z minus 3, and then we still have the 4z squared plus 9. Now, some students say, okay, we can factor, but what's the point? Why are we factoring, okay? You're going to see in the next section, section 4-5, factoring is a method we learn in order to make even more complicated, to find solutions to even more complicated problems, okay? Factoring is tough, but when you factor something, it makes it a whole lot easier to find the solutions to. Okay, 37, so we have 3r8 plus 3r5. Minus 60r squared. Okay, is there a common factor? Is there anything that goes into 3, 3, and 60? Sure, 3. And I can take an r out. Actually, an r squared I can take out. 3r squared times r6 is 3r8, plus 3r squared times r3 is 3r5, minus 3 times 20. And I took the r squared out of r squared, so it's gone. Does this factor further? Maybe. Let's see if we can factor further. R6, it could be R1, R5, R2, R4, R3, R3. There's R3s in it, so it's probably R3, R3. Okay. Last term's negative, so positive times a negative. How do we times to get negative 20, but add to positive 1? Well, positive 5 and negative 4. Okay. Those times to negative 20, those add to negative or to positive 1, and then we have 3r squared out front. Okay. Be careful here. That's a cube, but that's a square. You can't factor that any further than that. Okay. That was a weird answer. I'm just making sure. Yeah, that's what it says. Okay. All right. 39. Okay. Now they're asking, now let's get into some easier stuff, especially if you did well on the previous assignment, okay? If you did well on the previous assignment, you'll like this. You'll be getting to number 39, and be like, oh, I like these, okay? They want to know if something is a factor, okay? Tell whether or not this is a factor, okay? And they give us 39, 2x3 plus 5x squared, plus 5x squared, minus 37x minus 60. Should copy down, right? 37x minus 60 is x minus 4. Is x minus 4 a factor of this, okay? Well, forget about all this complicated stuff. If I asked you, is 3 a factor of 15? You'd say yes. And how you know that is because 3 times 5 is 15. Or you take 15 divided by 3 and there is no remainder, okay? If something's a factor, when you divide it out, it has no remainder, okay? So we're going to divide this out. We could either do a long division or synthetic division. I'm doing synthetic division, okay? I think that's so much easier than long division, okay? So if you remember what goes in the little box, the opposite of the number right here, so we put a positive 4. We have 2, 5, negative 37, and negative 60. Drop down your 2, times to 8, add to 13. Times to 52, add to 15, times to 60, add to 0. So, now what do? We're done. That's our remainder. The remainder is 0. If there's a remainder of 0, it is a factor. So is it a factor? Yes, it is. Okay, so is that all we click on? I got to check and see what it says on the assignment here. 39. Oh yeah, we just click on there. That is a factor. Okay. All righty. So we get 41. So we're finding out, does x plus 3, so I put negative 3, go into, no, I'm going to write this out. 41 we have 6x5 minus 15. 15x 4 minus 9x3. 9x3. Then x plus 3. Okay, now this one's a little tricky. We're going to put negative 3 in the box, then we're going to put down 6, negative 15, negative 9, but that's not it. We need placeholders, okay? X to the 5th, x to the 4th, x to the 3rd. There are no x squareds, there are no x's, and there are no numbers, okay? x5, x4, x3, x2, x1, no x's. You need to put in those placeholders, okay? So drop down your 6 times to negative 18, add to negative 33. Add to positive 99. Add to 90 times to negative 270. Add to negative 270 times to 810. I'm guessing no. Add to 810 times to negative 2430. Add to negative 2430. So the answer there is a big fat no. The reason is there's a humongous remainder, okay? This is not a factor of that, okay? So number 41, the answer is no, that is not a factor. 43. All right, what's 43 say? Okay, so 4, 3, 2, 1. Okay, so x plus 4 goes into, so put negative 4. I'm going to put one placeholder in here, though. We have 6x4 minus 6x3, 6x4 minus 6x3, minus 84x squared, don't forget the negatives, plus 144x, and there are no numbers, let's put a 0 there. Drop it down to 6, drop down to 6, times to negative 24, add to negative 30. Times to 120, add to 36. Times to negative 144, add to 0. Times to 0, add to 0. There is no remainder. Yes, it is a factor. Okay? 45. Okay. Last couple things we need to talk about. Let's get rid of this. Okay, now what they're asking is this. Now they don't want to know is this a factor, but they want to know, or actually let's show that it's a factor and then factor completely, okay? So we're going to show that it's a factor. So we have x5 or x3 minus x2 x2 minus 20x, x plus 4. So let's show that it's a factor. So we put negative 4 in the box, opposite of that. 1, negative 1, negative 20, 0. Drop your 1, times to negative 4, add to negative 5. Times to 20, add to 0, times to 0, add to 0. Okay? So it should have ended in 0, and it did, so that's good. Okay? So this right here is our remainder. This is our number. This is our x's. That's our x squared. So we have 1x squared minus 5x. Well, it's nothing. Okay? So this goes into this many times. We need to factor it completely, though. This factors further. So I can factor that to x, take an x out of that, times x minus 5. Okay, so we have x times x minus 5 times x plus 4. It's factored completely. If I multiply this all out, you would get that. Okay? Okay, where are we at? 47, are we doing 47? No, we're not. I'm skipping 47 and 48. On to question number 49. Almost done with this section. 49. So, 49, we have x3 minus 37x. 37x plus 84. We want x plus 7. Show that x plus 7 is a factor, okay? So let's show that it's a factor. So let's put negative 7 in the box. I'm going to have 1x3. I got to put a 0 in because there's no x squareds. Don't forget that placeholder. Negative 37, positive 84. Drop your 1, times to negative 7, add to negative 7. Times to 49, add to 12. Times to negative 84, add to 0. And it should have ended in 0, and it did end in 0, okay? So this is our remainder, this is our number, this is our x, that's our x squared. So left with 1x squared minus 7x plus 12. Well, let's factor this further. X squared is x and x. Look at our last term, it's a positive, so it's either plus plus or minus minus. There are no positives. There's a negative here, so we've got to have negative negative. How do you times to 12 and add to 7? 3 and 4. Don't forget the x plus 7. So factors to x plus 7 times x minus 3 times x minus 4. And that doesn't factor any further because everything is first degree. Okay, that's 49. Okay, what do we have? Like 2 more to go. We have to go 51 and 53. Okay, last ones we got to talk about. 51. They ask us to match the graph with the function with the correct graph. Let's explain the reasoning. It doesn't tell us to explain it, does it? We just have to do it. Let me just look here. Yeah, we just have to match it. Okay, so on 51, they give us f of x equals x minus 2 x minus 3, x plus 1, x minus 3, x plus 1. Okay, so what we do is this. We find our zeros. Our zeros are 2, 3, and negative 1. 2 makes this 0, 3 makes this 0, negative 1 makes this 0, okay? So if we plot these, 2 is right here, negative 1's right here, 3 is right here. Now, here's the deal, okay? This is third degree because there are 3 x's. Remember, third degree generally look kind of like this or like this, okay? It's not negative, so it's going up, so it's generally going up. If it's an even degree, it looks like a parabola opening up or open down. This is third degree, so it's going to go like, sort of like this, okay? Just a very quick, ugly, rough graph. That's all they want, okay? So let me look at the choices, and is there only one that looks sort of like that? Yeah, you should be able to figure that out. It looks like, what is it? D? Let me see here. D1. Yeah, it looks like the D one. Okay. Last one, 53. Okay, 53. Okay. So we have x plus 2, x plus 3, x minus 1. X plus 2, and 1. X plus 3, x minus 1. X plus 3. So again, my zeros are negative 2, negative 3, and positive 1. This is third degree. There's 3 x's, and it's positive. So again, it's generally going up. So we have negative 2, negative 3, and positive 1. It's going to go sort of like that. Okay, so that kind of looks like, which one is that? Looks like A. Okay, all right. Okay, a lot in this section. There's definitely a lot in this section, okay? But again, we'll be back in class on Tuesday for those of you that are not virtual. If you are still virtual, you can always email me and get back with me if you have questions. This assignment is due, again, I'm going to post this, have you guys do it, started on Friday the 15th, and next Thursday, January 21st is when I'm planning having it turned in by, okay? All right, email me if you have questions. We'll see you later.